This recording is for my grade 10 students to demonstrate preparation for the test on Friday. I'm solving some questions posted on Teams as an example. Question number 35. 2x squared minus 5xy plus 2y squared. The task is to factor this expression. We recognize this as a trinomial. It has three terms, 1, 2, 3. The standard approach will be to break down the middle term into 2, so we can have 4 terms. Question, how do we break down the middle term? First, let's observe the coefficients in front of the first and last term, which is 2 and 2. We multiply them together to get 4. And then we think, what are some other options for 4? What are some other factors of 4? 4 times 1, 2 times 2. If we have 4 times 1, we possibly could create minus 5, which is underlined in pink. How can we create minus 5 if we have 2 and 2 or 4 and 1? From 2 and 2, possibly not. But from 4 and 1, I see that it could be negative 4, negative 1, and that will result in negative 5. So this is what I'm going to do. Instead of negative 5xy, I'll put negative 4xy, subtract, I should say 1xy, but I'm not going to write 1. That is in place of this whole expression, including the minus. Minus 4xy minus xy. 2x squared and 2y squared should stay. So now I have 4 terms, and I'm going to group them into the left and right group. Between two groups, we have to decide what are common factors. What do these groups share? So what do you see in the left group? They share 2, and they share x. Between the two first and second terms, 2x is common factor. When 2x is factored out, taken outside of the brackets, what stays from the first term? X minus 4xy. 2x has gone, 2 stays, and y stays. First group has been dealt with. Second group, let's see, what do they share? Your question is, what is the common factor between the two members of the second group? And I can see, I think it's just y, x. They don't share x, they don't share 2. So it's only y that they share. And I will take negative y out. If I take negative y out, only x stays inside brackets in the first term, and the second will be subtract 2y, which is actually quite convenient, because usually what we are trying to achieve that these two groups are the same. If these two groups are the same, they can be massively factored out. I just usually put my finger here, and I observe what's left. Something like if I was doing like so, and we clearly see that 2x subtract y are left. And the operation is complete. Ideally, there should be equal sign. And at the end, we arrive to this expression. There's a multiplication in between. That completes the work. So this on the right side is more like my thinking process, which I'm not really, maybe not even showing to the teacher, but that's okay if it's there on the right side. Another example will be example number 28 from the page that was posted on Teams. 9r squared subtract 25. I see that there is only 2 terms here, so breaking anything in the middle is really not the option. So what do? I hopefully remember the formula, difference of squares. difference of squares could be written as a squared minus b squared, or m squared minus n squared, and we should have it at hand, or remember well that that's how it folds and factors out. We just need to recognize very carefully 9 and 25 are potentially 3 that was squared and 5 that was squared. There's also r that is near I, and that is potentially squared as well. Now, I see that I identified my numbers. I create two brackets. One will be positive, one will be negative. What fills inside is 3r and 5. 3r and 5. And that's how we complete this question. Found one more question which we can solve from the same page. Question number 12. 21 a squared plus 33a minus 19. So this is a trinomial, 3 terms, and it has quite large coefficients. So before I proceed to my step where I usually underline first and last and try to multiply them, I should try and see if I can factor something out right away. Is there anything that these 3 numbers share potentially? Very soon I noticed that they share 3. 21, 33, and 90 can be divided by 3. So maybe I'll take 3 out right away, and 7a squared, 11a, and 30 will stay. And at that time, I say, okay, I'll deal with 7 and 13, which is 210, and some other ways to achieve 210, 21 and 10 is also 210. And conveniently enough, 11 can be made out of 21 and 10 by doing 21 minus 10. So we found the 2 numbers that will be suitable for breaking down the middle term into. 3 will have to always be there at the front with brackets. And instead of 11a, I will put 21a minus 10a. Minus 30 stays here. So just to clarify, it's plus 11a, which is 21a minus 10a. Let's make this a little bit more pronounced. This is not 9, this is a. And now I create 2 groups and identify what do these groups share. As usual, 3 will just have to be there. So 7a squared plus 21a share 7. So when 7a comes out of brackets, inside from 7a squared, only a is left. When 7a comes out of the bracket for 21a, only 3 is left. And just to confirm that 7a times a is 7a squared, 7a times 3 is 21a. In the second group, I see that the negative 10 is the common factor. And if I take negative 10, a will be left alone. And if I take negative 10 out of negative 30, it's plus 3 that stays. So we have an excessive number of brackets, and we should not lose track of where we are. I'm now making an observation that a plus 3 is a common factor between my left and right group. Again, 3 stays. A plus 3 And if I close a plus 3 in the same manner as I did before, here and here, I see 7, 8 minus 10 is left. Yes, this is a lot of brackets. We can actually let go of at least one pair of brackets, and we just can have 3, 8 plus 3, 7a minus 10. Because otherwise, the number of brackets is a little bit overwhelming. But that concludes the operation. Last example for factoring will be question number 30 from the questions posted. Actually 32. 4n squared plus 32n plus 64. My first intention is to try and see if I can take anything out, if these numbers share anything. And very soon I realized that 4 is what they share, and it can be taken out. So if 4 is gone and squared is left alone, 32 divided by 4 is 8. 64 divided by 4 is 16. So here, I could, of course, notice that this is a trinomial, and I should be breaking down the middle term, which is not incorrect. However, I can also notice a formula for a perfect square, which, if you remember, I'll put it here, something like, how about I use C and D? Squared. First number squared, last number squared, and double of their product. So I think I can see that this is the first number squared, and 16 is the last number squared, which is 4. And all I need to confirm is that 8n is double of their product. So let me say, I suspect that this is n plus 4. And I just need to confirm, let's say, first number squared is n squared, last number squared, 4 squared, and double of their product, 2 times n times 4. Is that going to give me expression in brackets? N squared, 2 times 4, 8n, 4 squared, 16. Of course, it worked. Great. So that makes it the answer. And then this brown part is more like my thinking process. But 4 times n plus 4 squared is the answer to the question. So that's how we approach solving trinomials and factoring. Hopefully you will practice and do well on the test. Good luck.